Welcome to UC Collaboration, a global name in unified communication, formerly Voice Bootcamp Inc. Hi, my name is Faisal Khan, founder of UC Collaborations. This is a CCIE Collaboration Foundation Self-Study Kit. In this particular video, we're going to focus on the first chapter of Infrastructure and Services. Here, our agenda is to get an idea about voice VLAN, data VLAN, and how it is configured in voice environment. Native trunk followed by CDP, DHCP, and NTP server. Now the topology that we're going to focus on is based on our previous certification CCIE voice. Now as of January 2014, at the time this video was being recorded, that this topology is still pretty much unknown. So hopefully as the days come by we will get a better picture as to what the exact topology will look like. But based on our study about the CCIE collaboration and the changes that are being taken place, we assume that the topology is going to remain the same. But regardless of the type of topology that you get, once you have the basic knowledge about infrastructure level and what is required, it really doesn't matter what kind of topology they provide you. You should be able to apply those settings regardless of the type of design that they come up with. So let's explain the topology and what we're expected to do. Here we have, for example, 3 site location. We have head office with two IP phone, HQ phone 1 and phone 2, with connected to a switch called switch SW on the port number 1, 2, and 3. We also have an HQ router which connects to the switch in the same VLAN as these two phones is going to be, followed by a backbone connection which ultimately goes to the backbone call manager servers. Now the HQ side on the at the same time has a T1 connection to your service provider. It has a frame relay connection to the IP backbone, which in return lets you connect to site B and site C. So this is basically the HQ. Now keep in mind, the servers are located in head office, but they are not in the same subnet as the Cisco IP phone. Now let's take a look at site B. In site B, we have a router, 2800 series router, with 2 IP phone directly attached to the router. Now these IP phones are connected to a module called Ether switch module, 4-port switch on that particular router. In some cases there are 8-port or 8-port switch. Like HQ, site B router also have a T1 connection to the PSTN for our TDM connectivity, and then it has a frame relay connection to the backbone. Now site B, HQ, and site C router, they all have the same iOS code of 15.1 and so and so. Now site C router on the other hand is considered to be a site in either in Asia, for example. Now most likely Hong Kong for take it for example. Now site C router has a EU1 connection to the PSTN. It also has a frame relay connection, and it connects to a switch which is shared by HQ. Now in our lab we are sharing the same switch for both HQ and site C. The difference is that on HQ the first three ports are used on the switch for HQ site, and the last 3 ports are used for site C site. You also have two IP phone. Those are 9951 phone connected to one 9951 video phone and one 7961 regular phone attached to site C. On HQ side we have both 9951 video phones at this stage. On site B, both of these phones are 7961 per se. So this is your site specific devices. Then you have the backbone area. In the backbone we have an NTP server, a backbone gatekeeper, and a cube server. We also have a backbone call manager to establish a SIP trunk, And then we also have a PSTN phone which pre-configured with bunch of PSTN numbers, as you can see on this list. Now this area where you see remote access, this is how we log in remotely to our topology, so just an FYI. We also have a console server that we telnet into it, and in order to access any of these devices. So this is the topology that we're going to build on. So let's get some theory in our belt before we start configuring a specific site. So first of all, VLAN. Now hopefully we all understand what is a VLAN is about. Now VLAN in this case will be required in order to segregate voice and data traffic. In CCIE collaboration lab, VLAN must be configured for different type of switches such as 3750 or Ether switch module. You must trunk the port when is needed, and VLAN must be allowed on the trunk port wherever it is needed. You must also configure the native VLAN properly, because sometimes the native VLAN may be misunderstood, because by default all Cisco port that is trunk, the native VLAN by default is 1. However, in our voice environment, the native VLAN should be our data VLAN. Whichever the VLAN number that is, it should carry the data VLAN traffic. Now the VLAN task, you will be required to configure VLAN on switch port for the IP phone located at HQ, Site B and Site C. Voice VLAN IDs, for example HQ, Site B, Site C, are provided respectively 10Y, 30Y, 50Y. Y is your pod number, for example. Now this is we're going to assume that there is a machine connected to each switch port, so that therefore data VLAN must be immediately come into mind. We must configure the switch port such that machine will be placed in appropriate data VLAN, even though if the port happens to be a trunk. Data VLAN IDs, for example, for HQ, Site B and Site C are respectively 20Y, 40Y and 60Y. Now we're going to refer to the port assignment on your spreadsheet and make sure the VLAN IDs are detailed tables are located on the spreadsheets provided in your classroom, or you can download it from our website at www.uccollaborations.com under the client resource menu. Now steps for creating VLAN. First thing you want to do is check CDP. Cisco IP phone use CDP protocol to discover various elements of the configuration, such as what is going to be the voice VLAN, what is going to be the data VLAN. Also looks for CDP allocates appropriate amount of power to ensure that the phone is able to power on. Step 2 is to create the VLAN and VTP. Now VTP is not really required. You don't have to configure VTP unless you have multiple switches connected to each other directly. Because these switches are independent, so VTP is not really important, but the VLAN is. Now you must assign the VLAN once it is created. So we're going to create a data VLAN and voice VLAN, and we're going to assign them to appropriate ports. Now you have a router port which connects to a switch port, for example. You gotta make sure, because the router is going to carry traffic for both voice and data, it is possible for the router to carry multiple VLAN. So therefore the port on the switch where the router is connected must make sure that that particular port is trunk and all the VLAN that is required to go through the trunk is enabled. All voice port must be trunk if it is Ether switch module, even though although you can configure without trunk, but sometimes it can cause problem. We can just simply ignore it and ignore the fact that it is an IP phone connected to it. We're going to trunk it, because every Cisco IP phone has a 2-port built-in switch. That means you could have multiple VLAN coming through that too. Who knows? So always trunk the switch voice port on Ether switch module. You gotta make sure that all the trunk port must have a native VLAN set appropriately, and define DHCP server to assign IP address once the infrastructure is ready. So one of the first thing that we want to do on the switch level as we for CDP is to check to make sure the CDP is running. We type the command show CDP on our switch. Now CDP can be enabled on a global configuration level, like if you type config T and then type CDP enable. It is recommended that for Cisco IP phone to work properly that you advertise the version 2 of CDP. Now these are some of the items or things that can be easily disabled, and most often a student may not pay attention to it. Now you can enable CDP on a per interface level if you want to disable it globally, and only run on a particular interface levels and enable on that particular segment, for example. Now you can disable CDP by saying no CDP enable on a particular interface as well. Now to create a VLAN on a switch, type config T VLAN 506 or whatever the VLAN number. It is important that you name the particular VLAN so that you have an idea about what the purpose of the VLAN is. So always name the VLAN appropriately, even though name is not absolutely required, but it is good for documentation. Once the VLAN has been named, you need to apply them to your port. Now this is when you use the Ether switch module, we usually trunk the port, define our encapsulation, our native VLAN, which is the data VLAN, and our voice VLAN, which is 506. If you're using 3750 switch, then no need to trunk the port. Simply provide access VLAN and voice VLAN command to assign the VLAN appropriately. If you trunk both switch port type, then that's not a problem either. Now once that is done, we're going to focus on DNS, network time protocol, DHCP, call manager base or iOS base. DHCP is required in order for Cisco IP phone to obtain IP address. In the DHCP, we're going to assign IP address and network mask, default gateway, option 150, which is the IP address of your call manager or call manager express. DNS server is optional, not required. Now in order for certain IP phone to reach the DHCP server, which may not happen to be in the same subnet, we must configure IP helper address in order to forward the DHCP request to the DHCP server, because DHCP requests are broadcast and router does not forward the broadcast. Now keep that in mind, CDP is required in order for Cisco IP phone to communicate in such infrastructure. During the defining DHCP in call manager. Now call manager server can provide DHCP for limited number of phones, although Cisco does not recommend to use call manager as your official DHCP server for the entire organization unless you are less than 1000 workstation or IP. Now you can activate deactivate DHCP monitor process by using the serviceability window of call manager. You can follow the procedure in call manager service activation. So we are going to configure DHCP in call manager by going to the system menu, followed by DHCP, and add a DHCP server. So in the call manager, you will go to system menu, select DHCP from the list, and then you can choose DHCP server. The first thing you need to do, define which subscriber or publisher is going to be your DHCP server. So I'm going to log into one of my call manager. So you can access the DHCP settings by going to system menu. Now if you notice how I'm not getting any of these menus, this is due to your browser incompatibility. When you have this situation, simply go to tools menu, select compatibility view settings, and add that IP address of the call manager. You will get a little error, which is fine. Just go back to the IP address. So first we go to DHCP server, add a new server, select from the drop down list that publisher is going to be my DHCP, and you provide all the necessary details. So for now we just simply leave with the host server name. Once that is done, you're going to create subnet, and one for each particular site. So here we're going to define the IP address of our HQ site. Define the first IP address and the range of last IP address in the range. An important thing is a primary router, that is the default gateway. Now you also need to define the IP address of your call manager, which is option 150. For example, in this case 142.13.60, well, my mistake, 14.64. Well, I think I'm on the wrong server. So this is the right server. So this is the settings that I need for my HQ DHCP settings: the subnet address, the starting range, the end range, the default gateway, as well as my TFTP option 150. You also need to define your mask. So this is for HQ site. We'll make a new copy of it for site B. Just have to change the third octet for site B. Same call manager, TFTP option 150. There we go. So I got a DHCP server with 2 subnets. Now in order for HQ phone and site B phone to communicate with the DHCP server that is located in different subnet, we must define the IP helper address. Otherwise DHCP traffic will not cross there. Now before we do that, we must configure our VLAN and switches on the router level. So I'm going to show you how to configure VLANs on specific site. So the first thing I'm going to focus on is getting our HQ site going. So we're going to configure the switch, router, and this 2 particular phone. So this is my switch which connects to both HQ and site C. If I type show CDP neighbor, I should see all my devices, 4 phones. Obviously, as we say, that port number 1, 2, 3 goes to your HQ site. Port number 6, 7, 8 goes to site C. So first thing first, configure T. We're going to create the VLAN 103, name R3 HQ voice, VLAN 203, name R3 HQ data. This is my data VLAN and voice VLAN. So I'm right now focused on only the HQ side. Then I'm going to assign the voice VLAN and data VLAN to the HQ phone. Based on our topology, HQ router, phone, as well as the switch are connected to port 1-3. So I'm going to use a range command saying range fast Ethernet 0/1-3. Again, you don't have to trunk 3560, but I just do it force of habit. We're going to define the native VLAN as a data VLAN 203, and the voice VLAN is going to be 103. no shut, switch port mode trunk, and if I type show run, I should see something similar to this. This should be my switch configuration on first 3 port connecting to HQ, which is port number 1. Phone 1 goes to port number 2. Phone 3 goes to port number, phone 1 goes to port number 2. Phone 2 goes to port number 3. Now once this is done, we will go to the router, and in the router we're going to first make sure we can ping the call manager. So pinging is fine. We also want to make sure we can ping a source ping so that our routing will work properly. So source it from this particular IP, that is the voice VLAN interface, and I am able to communicate without any problem. Now type show run. A DHCP request from the Cisco phone will arrive on the voice VLAN, which is 142.103.64.254. So in that particular interface fast Ethernet 0/0.103, we must define the IP helper address and the IP address of the call manager server, because that is the DHCP server. So IP helper address points to the DHCP server, so that when a broadcast comes in, the router will convert that broadcast into unicast and then send it to this particular IP for obtaining an IP address. Okay, so that part is done. We can do a debug IP DHCP server event to see if there's a packet passing through. You can also say a packet. Just making sure logging console is enabled. On the switch level, if I type show CDP neighbor, you notice how my router 1 is being there. HQ router is there. And then I'm going to do a little bit more digging on the show CDP neighbor fast Ethernet 0/2 details. So that gives me more details about what kind of device that I have. What is the IP address? Should also give me an IP address once it obtains one. So as you can see, a request is being sent. Okay, so while we wait for HQ phone to obtain an IP address, we're going to go ahead and configure site B right now. So site B is on the site B router. If I type show CDP neighbor, I noticed my 2 IP phone connected to port 0/1/0 and 0/1/1. So again, config T. Let's create the make sure CDP is enabled. CDP run, advertise version 2. We must do this on switch 2 as well. Okay, going back to site B, we're going to first create the VLAN. So this is the voice VLAN. And this is the data VLAN. Now site B already has part of your layer 3 base configuration is VLAN interfaces. You notice that VLAN interface is created there already. And this is actually an incorrect address. We don't need this. So this two interface, which is created based on your base config, but you notice they're down right now. The reason they're down because none of these ports where the IP phones are connected are part of any VLAN at this stage. So we're going to go ahead and assign them to appropriate VLAN. So interface range So final config will look something like this for those two particular ports. Now the IP helper address must be configured on the VLAN 303. You notice how VLAN 303 just came up right now? That's because of the trunking. I must define IP helper address to the IP address of your DHCP server. And I want to make sure I can ping that IP address from my router using the source interface of this particular subnet. So pinging is perfectly fine. So save. So far what we have done, we have configured site B phone from obtaining a IP address from the DHCP server through the local router across the WAN. Now we're going to configure site C. So we're going to configure this particular site. But before we do that, let's see if if the IP phone found any details. When you tap show CDP neighbor fast Ethernet 0/2 details, you'll notice the MAC address of the phone and what IP address it has obtained. Now you can always take that IP address, copy for example, and try to ping that IP for the purpose of seeing if you're able to communicate with it or not. And then if everything is configured properly, you may also even try to web browser to that IP to verify some more details configuration. So if I were to open my web browser and paste that IP address there, okay, so web service may not be enabled on that particular phone, so that's why you're not able to see. Alright, so our HQ is there. Let's take a look at site B now. Site B, if I type show CDP neighbor fast Ethernet 0/1/0 detail, again it tells me what MAC address of the phone and what IP address it has obtained from the list. So right now I got my HQ phone IP address with the from the DHCP. I got my site B phone IP address from the DHCP. Now I'm going to configure site C phone with DHCP configured locally on the router. So on site C, I'm going to first exclude a range of DHCP. So anything between 1 to 15, 14 will be excluded, and then from 31 to 254 will be excluded. Now I'm going to create a pool. Option 150, IP address of the call manager. 54 and network address will be this. Now, by looking at the topology, you notice how this is my network. This is 142.1.0.66.0. This is the subnet, so this IP phone will get an IP address from this subnet. The default gateway for this phone is this IP address right of this interface, so which will be, for example, this. And if you're not sure about it, you can type do show IP interface brief, and it will show you what IP address it is using for voice VLAN. Now that is for the IP side. Now I must configure the switch, because this particular two phone has to be registered connected, which are connected to this switch on port 6 to 8. So we're going to configure, type show run to see those last three ports. Oops, my mistake, I'm on the wrong device. On the switch, if I type show run, you notice that port number 678 is connected to site C. If I type show CDP neighbor, port 7 and 8 belongs to the IP phone of site C. So now I'm going to configure VLANs. 503 name R3 site C voice, VLAN 603 name R3 RC data. Now I will assign those two VLAN to ports 6 to 8. To keep life simple, I will trunk them. So finally I should see the configuration as follow. It should be something like this. Now if I go back to site C, after few minutes I should see, if I type show IP DHCP binding, that I should see IP address assigned to those particular phone as well. So if you type show IP DHCP bind, it will see the two IP address assigned to those two IP phone. So I was able to obtain IP address, the phones were able to obtain IP addresses from the local DHCP server. So looking at the configuration one more time, this is my DHCP for site C, which allows these two phones right here to obtain IP address from the router. It will get an IP address from this particular network. This is the default gateway. Default gateway happens to be the IP address of this router. And option 150 tells which call manager to go and register to. This is the TFTP address. So once you configure the local router as a DHCP, in some cases you may want to create a situation where they might ask you to reserve a particular IP address for a particular host. So it doesn't matter how many times that particular IP phone is restarted or whatnot, it will always obtain the same IP address. Now to achieve that, if you take a look at the router, I have configured this as my DHCP. So all I have to do to make sure that a particular IP address is reserved for one particular phone and that phone will always obtain that IP address, well, first of all I need to know the MAC address of the phone, and then I must create a specific pool for that particular phone, saying IP pool, DHCP pool phone 1. In that particular pool, I'm going to have host, which is the IP address that I want to assign. So in this case, phone 1 will always get the IP address .12. Client identifier is the MAC address of the phone up to 02, and 01 is required in order for Cisco to kind of make it a static MAC address, client ID. So we must add 01 at the beginning of the MAC address. So MAC address will be deployed as follow: 0102.0010.0012.34. This is the this is the MAC address of the phone, and the client ID will be 01 plus the MAC address, but we have to write them in a group of 4, except the last 2 is going to be 2-digit. Then define the default router and option 150. Now this is done for every phone that is required as static or reservation. So if you have 20 phone that requires the same IP all the time, you must create 20 different pool. The alternative to that is to create a database where you don't have to create multiple pool for multiple phones. You rather create one particular text file that contains the mapping of all the IP address as well as the MAC address. This is more of a static mapping. We must create a data pool with as follow. First of all, IP DHCP database, which database to pull the information from. So I will have to create a text file called static.txt. In that file will contains the database of IP addresses. Then I create a single pool that I'm going to say obtain the origin file static.txt. Basically, as opposed to the network statement here, I'm going to say origin file / static.txt. And then of course you have your default router and your option 150. Now we will disable the DHCP first and then enable it so that the router can read this particular file. If the router has to read this file every time you update it. Then you create a text file that with the following format. As you can see, this is the format of the file: time, date, version 2, IP address, the MAC address, and the lease expiration is infinite. Basically never expires. So once you create this file, you save it, upload it to the router, and then type no service DHCP and then service DHCP, and you'll see the router will read the file and make sure proper MAC address is assigned the appropriate IP addresses. NTP is very important in IP telephony. NTP is required to be configured on all the site. If you want Cisco router to act as an NTP, you must type NTP master. NTP source loopback 0 basically says that all NTP traffic should originate from the loopback 0. Now if I want my HQ router, so if I look at my topology, I want the HQ router right here to act as NTP for all my internal device. So I'm going to say NTP master and then NTP source loopback 0. Now if I want NTP to connect to an external site, then I will say set clock set time zone PST -8, and then I'm going to say NTP server IP address my NTP server, which is 135.11.11.11. Okay, so once that is done, you can wait for a few minutes and then type show NTP status. It will show you ultimately that it's synchronized. For site B, I will simply point to clock time zone CST -6, and then I'm going to say NTP server IP address of the loopback of HQ router. For site C, same thing. You can configure NTP on the call manager as well by going to the OS administration, select settings, NTP server, select the NTP server and the host name of the IP address. So this is a practical questions you may want to follow. This will be the type of questions you'll be provided in your possibility in your lab. So you can use this as a practice to conduct the lab on your home lab or rack rental place, or even in a training center where you're taking this training. So this will be the end of our chapter 1 for infrastructure and VLAN, and I will see you in the next chapter. So the conclusion of this module is that you must create VLAN, assign them to the IP phone, enable VLAN on a trunk port in case if it is not allowed, route a port if it is already trunk, verify that all the necessary VLAN is configured, ensure VLAN names are configured, DHCP must be defined properly, if incorrect information will cause unnecessary troubleshooting, verify all the scope settings, and ensure that NTP is configured properly.